Assalamualaikum warahmatullahi ta'ala wabarakatuh. Shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Right, bismillahirrahmanirrahim. So this is our second class. So first of all, I would like to share a short tazkirah. This is from Surah Al-Ghafir, Surah number 40, verse 81. Which is about signals or signs where Allah also shows His sign. And what are the most important that are we reflect what have He shown to us? Okay, so in this ayah He said, and He shows you His signs. Okay, so which of the signs of Allah do you deny? All right, so the creation of human being, the moon and the earth are all the sign of Allah existence. Okay, so from this sign we can think that Allah exists and Allah is here for you, and inshallah where if you feel hard or tough in this life, just make dua to Allah subhanahu wa ta'ala. Alright, so also in verse 30, and among His sign is the creation of the heavens and earth, and the diversity of your languages and colors. Indeed, in that are signs for those of knowledge. Alright, so we know that we are created in this world for temporary. So when He said that at the end of our life, He will give us either heaven or hell. So in this world, we should strive for the excellence and grab the best heavens in the hereafter. Okay, so when you look around at your IIM in this world, there are a lot of people with different races, different languages, and different from different nations. Okay, so those are also signs of Allah. All right, so I hope we can embrace these differences and also strive the excellence in the world and also in the hereafter. Okay, so we go back to the technical meaning of signal. Okay, so usually when you look at this screen, it says that no signal. Basically you can imagine this is our television. So in the television we need a signal for it to appear something. So it has to be an input for every system. Okay, so if our TV or television don't have a signal, they cannot display the video or the story that we want to look forward. Okay, so in this case, signal is an important input for the television, right? The next one is we have this example of a toaster. Okay, so when we input voltage to the bread, okay, so the bread will turn the color and burn. Okay, so we have the input electrical charge, or in voltage we call it, to be increased in the heat, and then it will burn to make the bread hot. Okay, so it will be the output. Okay, so usually when we have this, so we have a system, we will have an input and also an output. As what I have given example in the television system, when we have no input, we cannot have a output. Okay, so for example, we have an input at -1 to 1, the value is 1. Okay, so this is an input. So when it goes to a low pass filter, so it will make this rectangular become semicircle. Okay, so the input have to become from -1 to 1, but it's already in a different shape, YT. Okay, so this filter turns from this input to this output. Okay, alright, so this in example, this is a transmitted binary signal. So what it means for binary, it means it has two values, -1 and 1. Okay, so when it come across to a filtered signal, so the filtered signal will look like this one. Okay, And we also have another input, which is a filtered noise, or we call it as noise, okay? So when the noise and the signal is summed or added, so the input will be, looks like this one, okay? So this input at this point, for example, 1, okay? And here is 1, and here this is 0.5. Okay, so we add it at this point, it will become 1.5, okay? At this point, okay? So you can choose any of it, for example, this point, okay? This is like 0.8, and this is 1. Okay, so this one will become 1.8. The signal itself combined with a noise, okay? Alright, so we can try to define a signal as a real, okay, or complex. Okay, remember in the first class, it can be A plus IJ, okay, a complex number with a valued function of one or more real variables. Okay, it can be more than one real variables. So an example of a signal is a voltage across a resistor or current through an inductor. Okay, so from this voltage across a resistor or current through an inductor, it can be an input or signal to a system. Okay, the system is defined usually by the designer or engineer to create an output here, okay? Or we can have a signal as a pressure at a point in the ocean, okay? So that point in the ocean is a signal. Or amount of rate, usually in millimeter per hour at this location. Okay, so for example, we have rain at this location, 37.4 north and 132.16 west. Okay. Or it can be also a price of Google stock at end of each trading day. Means, for example, we put some price at a stock and then we invest, and at the end of the day it will be given a new amount, either loss or profit. Okay. Alright, so most of the time, especially in this course, the independent variable is time, but at some point in after midterm we will see that it will be in the term of frequency. So this is time, so this can be voltage, this can be pressure, okay, this can be millimeter per hour, okay, any values of signal, okay. So usually signal has units. For voltage it can be volts, okay, so for pressure it can be PSI, okay. So signals can or usually in principle be measured in GT, time, yeah, time. So for example, we plot the time exists starting from 0 to a certain values of time, and then we plot or insert some values of signal, okay. So the integrations of this area is total area, okay, at certain range to certain range, or we mention this value as squared, okay, so we call it as energy, okay. Alright, so usually in electrical and computer department or communications, we can look at this example. For example, our voice, okay, when we speak, it become signal, okay, and it pass to a transducer. So this transducer will transform the voices, okay, into electronic signal. So the electronics will process this signal in current or voltage, and then it transmit, okay. So our voice now is represent as a current and voltage, and will be transmit into a channel, okay. So this channel will travel using an electromagnetic wave. Okay, once it receives at the receiver here, This electronic signal will turn into the original signal, so the other person can listen to your voice. Okay, so basically we have this input, okay, and then this is the output. Okay, after it goes through some process, okay, so this is the system. Okay, all right, so this is another example where we have the reference input or voltage. So it will heat up the thermostat, okay, and then there is a heating element. So this is the plate of iron, okay. Okay, so it will heat up, and then we can control here whether you want minimum, maximum, right? Okay, so we can control the temperature. Okay, so this is also a temperature control system. We have this same process, but the difference block diagram, okay, for a different system. Okay, okay, so in formally we can define a signal as a functions of independent variables, okay, that carry data or informations. Okay, so it can be electrical signal, acoustic, where we have speech or voices or audio, right? And then we have video signals. Okay, so video signal is actually an intensity variation. So where we have an image that combine, it will become a video. Okay, and then we have these biological signals where it can be generated from our body or a gene. Okay, genetic. Okay. Okay, so the next, just now we have learned the introduction of what is signal, okay, and then we will cover what is the signal operation, signal classifications, and also signal representations. Okay, signal operations means that what we can do with that signal. If we want to delay, we want to advance, we want to reflect, or we want to identify what is the odd and even components. Okay, these are signal operation that will help us in their representation and processing. Okay, after we know a signal, that we identify a signal, so we will operate them. Okay, and then we also can classify signals. Okay, some signal is a energy signal, power signal. Okay, so we can also classify it. Is it can be stored? Is it can be processed? Is it linear? Okay. So the next one, maybe I will just cover two for today's lecture. The basic representation. So we want to show how to represent a signal in the mathematical identification. Okay, so when we know how to represent a signal, we can know what is the Fourier representation. Okay, so let's see the first three. Signal operation. Okay, basically a signal can be scaled up or scaled down, and then a signal can be reversed. Okay, and then a signal can be shifting or delayed, right? Okay, for the first one is time scaling. Okay, whether we want to compress or we want to make it bigger, okay, or want it compressed. Okay, so for example, we have this signal xt exists at t1 and t2. Okay, and let's say this is a. Okay, so when we compress, that means we make the signal become smaller. Okay, so the value here is x to t. Okay, so what happened to the t here, the original time t, so it will be divided by 2. Okay. Okay, so whatever the value here, okay, so it will become t divided by 2, and whatever the value here, t divided by 2. So from t here, t divided by 2 means it will get smaller. Okay. Or we want to make this signal expand. Okay, just now compress being small, expand become bigger. So the x, we make this operation t divided by 2. So means the original t here have to multiply by 2t. T2 here multiply by 2t. So we put this divided by 2 to outside. Okay. So 2t for just now is 2. So here become 4. Okay, so minus 2 minus 4, and then this is 4. And if this one is 2, so this one will become 1. This one also become 1. Okay. Alright, so if you see a system defined as or an output is yt, input is xt. Okay, so this is input xt. So the xt is x2t, means the output will be compressed. Okay, we make this one divided by 2 and expanded. So the output is defined as xt divided by 2. So the divided by 2 will be going out. So 2 multiplied by t at the of the input. Okay. Right. Okay, so let's see this example. So this is a combination of a rectangular here. Okay, this is a rectangular. Okay, and then this is a 2e minus t divided by 2. So the point here is 3 and this is minus 1.5. Okay, so if let's say the y, the output, okay, so this is y, yt, this is xt. Okay, it's defined by x3t. Okay, so means that the value of 3 here now become 3 divided by 3. So 1 is here. Okay, so minus 1.5 divided by 3. So 0.5. Okay, so in this case, yt is xt divided by 2. Okay, so you take it out. So now 3 multiplied by 2 is 6. 1.5 multiplied by 2 is minus 3. Okay, so it will become expanded. This one compressed. Okay. Okay, the second operation is time reversal. For time reversal, reverse means you make it from positive to negative. Okay, so from positive to negative, whatever the value here, T2 become minus T2, and whatever the value minus T1 become T1. Okay, negative, positive, positive, negative. Okay, so you like flip or put a mirror here to reverse it. Okay, so for example, this is 5 become minus 5, and minus 2 become 2. Okay, so this point also you reflect. Okay, reflect here, so become here minus, and here reflect. Okay, to here. Okay. Alright, so if a signal xt is delayed by t seconds, okay, now we go to the third operation, time shifting. We want to delay, okay, we want to shift the time t here. Means whatever happens in input xt will also shifted in the output yt. Okay, so yt plus t means we want the output to be shifted by plus t. Okay, so yt is equivalent to xt minus t. We move it to the other place. So for example, we have function xt. Okay, this is the input. Now we want to delay. Okay, so we want to delay. Okay, delay. Okay, so means the time have to be minus t. Okay, if we want to advance, the t will become plus t. Okay, so what is t? T, for example, is 4. So t1 plus 4. So this is 4. Okay, we go to the right. Okay, to the right, minus t, and advance to the left. Okay, so another example, this is function e minus 2t. Okay, now we want to delay, okay, to the right, delay. Okay, if delay, we put a minus 1. And this is advance plus 1. Okay. Alright, so this one to the right is delay and this is advance plus. Okay. Alright, so let's say we want to combine that function not only shifted by b but also scaled by a. Okay, so you can either use two methods. First of all, you do the scaling first. Okay, when you scale first, that means you have to move to the right. Okay, to the right, and then this value you multiply by a. Okay, this value multiplied by a. Or if you scale first, okay, if you scale first, you will affected the shifted by b over a as well. Okay, so if you want to shift first, and then when you if you want to scale it first, and then when you shift, you will have to divide by b over a. Okay. Okay, so for example, this is x scale by 2 and delay by minus 6. Okay, so this is xt, the input. Okay, the input from minus 1 to 1. Okay, and then when we said x2t, remember the first operation, x2t means the time is divided by 2. Okay, so this is 1 divided by 2, so it will become shifted or compressed here. Okay, and then the shifted value is 6. Okay, because we do this operation first. Okay, so now the value become 6 divided by 2. Where this is 2 come from? From this one, b divided by a, the shifted divided by the compression value. So this is if you choose to compress first. Okay, all right, now we choose to shift first. Okay, so this is the function minus 1 to 1. Okay, we choose to shift first, so the value of the shifted is minus 6. So minus 1 plus 6, okay, 5. 1 plus 6, 7. Okay, so this minus, right? So you go out, it become plus 6, yeah? Okay, now we haven't do the x to t. Okay, so whatever the value divided by 2. So the output is should be the same. Okay, so this is compress first, this is shift first. Okay, alright, so the following are basic signal operations, okay, in the representations and processing of signal. Okay, basically we have time and frequency shifting. Okay, either we want to shift the time or we shift the frequency. So the first says that the signal xt is delayed second to get xt minus t. Okay, so it will be delayed in this time and advance by to get xt plus t. Okay, so just now it's delayed and this is the advance to the right and this is to the left. Okay, so a signal can be shifted in frequency or frequency modulated by multiplying it by a complex exponential or a sinusoid. Okay, so if we later in the time we have a function that shift from time domain to frequency domain. Okay, so if we want to shift the frequency, okay, so we will multiply the function by e minus xt. Okay, so t is the value of the delayed or advance. Okay, so this is in the frequency domain. Okay. Okay, for the time scaling, the time variable of xt is scaled by a constant to give xat. If a equivalent to -1, okay, so the signal is reversed in time. So means it has a -1 just now, a. So a equivalent to -1. So it means it is reflected. Okay. Okay, for a operation that consider a addition, so signal xt, the first signal, and yt is the second signal, will be added. So the output will be zt. Okay, so that is the sum of x and y. Okay, and then we have multiplication, constant multiplication, mean signal multiplied by a constant. So a x t. Okay, or we also have a time windowing. So windowing is actually like a filter. So this is a function, and then it says the window is wt here. This is wt, so it will only have a signal at this window only. Alright. Okay, so this is the diagrams of a basic signal operation. Okay, so for the first one is adder, so that's mean xt plus yt, we have zt. Okay, and the second one is the multiplication or constant multiplication. So this xt will be multiplied with alpha or a value, so the output will be axt. And then if we have this block diagram, it says that delay tau. So this function will be minus tau, delay tau. Or this is a windowing, xt multiplied by a filter, like for example, or window, wt, so xt multiplied with wt. Okay. Okay, I'll stop here first, and I hope if you have questions, you can digest first, and then if you have questions, we'll discuss in the class, alright?